Well, this video is about secants, tangents, and angles. But before we get started, there are a couple of basic concepts I need to go over. Okay, first, let's talk about central angles. A central angle is an angle whose vertex is at the center of the circle, like this one. The central angle has the same measure as the intercepted arc. Okay, this would be the intercepted arc. So if this angle was, for example, a 30-degree angle, then the measure of this arc would also be 30 degrees. Now, sometimes instead of seeing just a single angle, you will see it drawn this way with sort of a pair of angles. But notice how they meet at the center. So that creates additional information because these are called vertical angles and they are always equal. So I know that these would both be 30. And then I have another intercepted arc down here, and that would be 30 as well. So I need you to be comfortable with this sort of as a formula also. So here's the same thing as a formula. I mean, it's going to be a really simple formula, but still. So if this is the center, and again, okay, I've got this pair of central angles. If the central angle is theta, then the arc is also going to be theta. Actually, okay, here's what I meant to say. So here's the intercepted arc. We'll call the angle theta. Let's call the arc x. But if we're dealing with a central angle, then theta is equal to x. Okay, there's my simple formula. Now, let's look at a similar situation, but this time the angle will not be at the center. So you can still imagine that the center of the circle is right here, but when I draw my angles, they will not be at the center this time. Okay, so I still have my angles, alright, so this is theta, this is also theta up here. I'm not going to write it twice because it's the same thing, but now I have to talk about two intercepted arcs. I have to talk about this one and I have to talk about this one. Okay, I didn't have to do this before because the other intercepted arc was exactly the same. Alright, it was also x, so I didn't need to worry about it. But see how these are not the same? So I need to call one of them x and I will call one of them y. So the relationship here is that the angle is going to equal the average of these two. So imagine if you added these up and divided by 2. That's how you would get the angle. Or another way to write that is to say 1/2 x plus y. Okay, so the angle is the average of the arcs in this situation. So notes. You should be writing all of this down. You should have a sheet of paper and all of these examples I'm giving you, write them down. So this is the deal when the angles are inside of the circle. Now you can have an angle that goes outside the circle like this. So similar to the last picture, I have an angle that I want to look at, and I have two intercepted arcs. I have this arc and I have this arc. Alright, let's call this x and let's call this y, similar to what we did last time. So the formula is going to be very similar. The angle is going to equal x, but instead of being x plus y, it's going to be x minus y divided by 2. Or again, I could write this as theta is equal to 1/2 x minus y. So this is the deal when the angle is outside of the circle. Notice I'm doing x minus y. The order matters. It has to be the big one minus the small one. Alright, otherwise you're going to get a negative angle, and you can't have that. Alright, so I hope you're writing all of this down. You need these formulas to do the problems. Alright, let's tackle the first problem. A secant and a tangent meet at a 90 degree angle outside the circle. So here's a circle. So there's a lot of vocabulary in there. A secant is a line that goes through the circle like this. Alright, a tangent is a line that just barely skims the circle like this. Okay, that would be a tangent. Now these are supposed to meet at 90 degrees, so I'm going to draw this a little bit better. Okay, that's a little bit better. So this is 90 degrees right here. Okay, what must be the difference between the measures of the intercepted arcs? So we've got these two intercepted arcs. Okay, so the tangent touches right here, and then so this arc stops right here. So this is one intercepted arc right here. Okay, now the other intercepted arc goes from here all the way around to here. Okay, so let's call this x and let's call this y. And so this angle right here, this is the theta that we talked about. So this is the situation where we have the angle outside of the circle. So the angle should equal the big arc minus the small arc divided by 2. Okay, so the angle has got to equal x minus y divided by 2. But we know what this angle is. Alright, they meet at a 90 degree angle outside the circle. So that means 90 is equal to x minus y divided by 2. Now, we're supposed to find the difference between the arc measures, the difference between the measures of the arcs. The difference is subtraction. Difference means subtraction. So x minus y, that's the difference. So this is x minus y. So we're trying to solve for x minus y. So what you want to do is multiply both sides by 2. So if I multiply by 2 on both sides, okay, then these are going to cancel out, and that's going to leave me with 180 is equal to x minus y. So the difference is equal to 180. So that's why this is the answer. Kabam! Okay, next problem. What is the measure of angle 1? So we are being asked to find this angle right here. So this is this situation. So the angle should equal arc plus arc divided by 2. Okay, so the angle should equal the one arc plus the other arc divided by 2. So the angle is the measure of angle 1, which is what we're looking for. So the one arc is 37, the other arc is 25, and that's going to be divided by 2. So that's 62 divided by 2. So that means that the measure of angle 1 is 31 degrees. Boom! Oh, looky here. This is this situation. We have the angle outside the circle. So the angle is going to equal the big arc minus the small arc divided by 2. Alright, in fact, maybe we should just write that down. So the angle is going to equal the big arc minus the small arc divided by 2. So let's substitute in everything that we know. The angle, well, that's 72 degrees, as you can see, is equal to the big arc. All right, this is the big arc out here, and so that's going to be 360 minus x. Okay, that's the big arc. All right, minus the small arc, which is just x, divided by 2. So this is what we have. I don't like fractions very much, so I always get rid of them as fast as I can. So we can multiply both sides by 2 right from the start if we want to. That will cancel these out. So that's going to leave us with so that's 144 is equal to 360 minus x minus x. All right, see the minus x is there twice. So that makes 144 is equal to 360. Let's combine these like terms. So that'll be negative 2x. And now we're just solving for x. So let us subtract 360 from both sides. So negative 216 is equal to negative 2x. Now we just have to divide both sides by negative 2. So x should equal 108 degrees. And there you go. Well, in this problem, they are basically asking us for the formula. So looking at this situation, look at the notes, hint, 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 the notes that you've taken where you've written all of this down. Clearly, this is the situation that we're in on the right-hand side. So let's just write down our formula. The angle is equal to the one arc plus the other arc divided by 2. Now looking at sort of how they have it set up, I showed you that another way of writing that, instead of putting the 2 in the denominator, you could write it as a 1/2 in the front. So let's think of it that way. The angle is equal to 1/2 of x plus y. Now let's compare that to this. So we have the angle and then we have the 2 arcs. Well, for the angle I have 1 and 2, but they are the same. So I could use either one of them for the angle. But looking at our answer choices, they're using the measure of angle 1. So that's what we're going to do. So the angle, which is the measure of angle 1, is equal to 1/2. And then now it should be the sum of these arcs. So A plus B. So this is the answer. That's minus. All right. There it is right there. All right. Okay, if you chose this option down here, okay, so I see the C and the D. So just understand this, when we're dealing with angles and intercepted arcs, you see that we're dealing with the measure of angle 1. So we're stuck with that. So see how the angle 1 is inside here. So this is angle 1 going like this. Okay, so the intercepted arc is inside of angle 1. Okay, and this, what they have labeled as angle 2, that's also the same as angle 1. And again, the intercepted arc is down here. So C and D are not the intercepted arcs. They are not inside of the angle. and those are the arcs that you want, the ones inside the angles. Alright, again, see how this angle is outside the circle? That means we're in this situation right here, where we're doing angle is equal to big arc minus small arc divided by 2. So that's what we're going to do. So the angle is equal to the big arc minus the small arc divided by 2. So the angle is this right here. So that's going to be 45 degrees. The big arc is this right here. Okay, I don't know what that is, so I'm just going to call it x for now. So x minus. Now the small arc is this right here. Okay, that is 83 degrees. So x minus 83 degrees divided by 2. So I can solve this for x. I can find this arc up here. So let's go ahead and do that. I'm going to multiply by 2 on both sides to get rid of this ugly fraction business. So that's going to give me 90 is equal to x minus 83. And then I'm going to add 83 to both sides. So that is 173. Okay, and I guess that's it. That's what they're asking us to find. The measure of arc PO. And that's what this is. So the answer should be 173. Let's check it out. All right.